Questions? Okay, let's look at an application from physics. Ready? If two resistors with resistance R1 and R2 are connected in parallel, then the total resistance R follows this equation, measured in ohms, is given by this. If R1 and R2 are increasing at rates 0.3 ohms per second and 0.2 ohms per second respectively, we are asked to find how fast is R changing when R1 is 80, and we don't care about that till the end. R1 is 80 and R2 is 100 ohms. So we're given this relationship, 1 over R equals 1 over R1 plus 1 over R2. So that was problem 27, and this is my page 9. On page 249. So it's 1 over R plus, not plus, equals. I'm going to erase that, sorry. 1 over R1 plus 1 over R2. We are told that 0.3 ohm, and what was that? 0.2. Please identify what those are. Oh, of course, per second, right. What are they? Sorry about that. What is this and what is this? dr1 over, very good, and dr2 over dt. So we're asked to find what when R1 equals 80 and R2 equals 100. Is that 80 and 100? I'm pretty sure, but I'll rather check. Yes. So what are we asked to determine? Of course, dr over dt. So I'm going to copy this. Can anyone tell us how to copy it so it's useful for what I need to do next? Of course, thank you very much. Equals.
R sub 1 and negative 1.
Excellent. This is the easiest thing to do. Good. So the next step, please.
Differentiate.
Good. Can anyone give us the first step?
Negative 1 R and negative 2.
Very good.
dr over dt.
Very good. Do you all agree with the left-hand side? Negative 1 comes in front. We subtract 1 from the power, and since they're all, I should have asked, my apologies. What do we know about all these? Functions of time. Perfect. So then, negative 1 times R sub 1 to negative 1, or R1, dr1 over dt, and minus, I should write plus, negative 1, R2 to negative 2, dr2 over dt. I will multiply everything by negative 1 so I don't have to worry about those. Now I can go back to 1 over r squared dr over dt equals 1 over r1 squared dr1 over dt plus 1 over r2 squared dr2 over dt. And remember, this is what we want to determine. That is our only variable here. Ready? So what do you recommend now?
Multiply by
Excellent. R squared, 1 over R1 squared, dr1 over dt, plus 1 over R2 squared, dr2 over dt. And yes, now when R1 equals 80 and R2 equals 100, but I have one tiny problem here. I need to determine this when R1 is 80 and when R2 is 100. Because the rest I have, right? I have this as being 80 squared. I have this as being 0.3. I have this as being 100 squared. And I have this as being 0.2. Those I have. But I have to determine R. And the relationship is 1 over R equals 1 over 80 plus 1 over 100. So when R1 is 80 and R2 is 100, I have to determine R. So I need the least common denominator, which is, so this is 2 to the third and this is 2 times 5. I just disregarded a 10. I can put 1 over 10 in front so I don't worry about it. So, so 8 and 10. Yes, 2 to the third and 2 times 5, it has to be 40. Perfect. So 40 divided by 8, this will be 5, and 40 divided by 10, this will be 4. So this is 9. So 1 over R equals 9 divided by 400, and now I flip. I'm allowed in a proportion to flip both at the same time, or just cross multiply. R equals 400 over 9 ohms. So this is what I have to put in R squared. So finally, we have this. dr over dt equals 400 over 9 everything squared, 1 over 80 squared times 0.3 plus 1 over 100 squared times 0.2. Okay, so let's do this. So be very careful now. So we have 400. Let me see how I want to do this. Yes, I want to put parentheses, of course. So I have 400 divided by 9, everything squared, a left parenthesis again, 0.3 divided by 80 squared, and then plus 0.2 divided by 100 squared, and then close the parenthesis. I got 0.132. And what does this mean? 0.132. Measurement unit, please. Measurement unit? Thank you. Indeed. Great job. Okay. Let's see what else I can entice you with. Yes. What about 16? Let's read 16. A spotlight on the ground shines on the wall 12 meters away. If a man 2 meters tall walks from the spotlight towards the building at a speed of 1.6 meters per second, how fast is the length of his shadow on the building decreasing when he is 4 meters from the building? A lot of information. So let's start from scratch. A spotlight on the ground shines on a wall 12 meters away. So that's my first step. And this is problem 16 on 248. 248. 16 on 248. So here it is. Here's the wall. Here is the spotlight. And here's the distance of 12 meters. This is what I know from the first sentence. Any questions? Okay, so far? Then, if a man 2 meters tall walks from the spotlight towards the building, I cannot draw a man. I'm sorry.
That's pretty good.
Thank you. He walks this way. And he covers this distance, which I'm going to call x. So imagine that's the wall. The spotlight is right there on the floor. I'm not 2 meters tall, but I'm walking towards the wall. So this is the distance that I cover, and I'm covering it at a certain rate, right? So here's the spotlight, and I'm going this way. So this distance increases, and I'm covering it at a particular rate. What is the rate for this man?
dx by dt.
Excellent, very good. So towards the building at a speed of 1.6 meters per second. So that's exactly it. Indeed, dx over dt equals 1.6 meters per second. Great job. Let's read on. How fast is the length of his shadow on the building? Okay. How fast is the length of his shadow on the building decreasing? So when I'm here, my shadow is huge. When I'm getting closer and closer to the wall, my shadow decreases as much as my height at some point in time. Okay, so how fast is the length of his shadow on the building decreasing when he is 4 meters from the building? You know, the when and where have no meaning at this point. 4 meters away from the building. 4 meters from the building, which means x must be perfect. But what am I asked to find?
dy by dt.
Very good, indeed. I'm asked to find dy over dt. Let's review everything one more time and decide if you have any questions. So here's the spotlight. There's the wall. The person walks at 1.6 meters per second towards the wall. At the same time, his shadow on the wall is decreasing. And we want to find that rate. And at a particular instant, when he covers 8 meters, right here, 8 meters away. So, what do we do? We have one piece of information that I did not put in the figure. And here is the piece of information. Extremely important. I know that this is a rate. I know that I'm looking for this rate. Somehow I have to relate them. I have to come up with an equation that relates x to y. If I can't come up with that equation, then I will not be able to differentiate and plug in 8. So here's my hint, and I'm hoping you remember this. What am I hinting at?
Similar right triangle.
Thank you very much. Small triangle is similar. That's a notation for similar to the big triangle. So the pink triangle and the black triangle are similar. But I have to show why. I cannot just say, oh, they're similar, move on. No. I have to show 2 sets of congruent or equal. We like congruent. Equal. two sets of congruent angles. If I manage to show that, then they are similar. If I can't show that, then they're not similar. But we see already two pairs of angles. First of all, they're both right triangles. You agree? Secondly, this angle is common in both, so it must be the same. So therefore, indeed, two right triangles and a common angle, of course the third one must be the same, there is no other way. They are similar, but now I have to write proportions. That's the key here. I'm using similar triangles because the similar triangles will allow us to write proportions for their sides. But we have to be very careful how we write those proportions. You cannot just say x over 2 equals y over, you can't. You have to be very careful. So let's start with a common angle from the small triangle. What is the opposite side of the common angle in the small triangle? 2. So 2 goes to the top. Same angle. What is the opposite side of this angle in the big triangle? Y. There is no point in using this angle because I don't know anything about this and I don't know anything about that, so this is not useful. But now I know that these two angles are congruent or equal. I have to start with a small triangle. What is the side opposite to this angle in the small triangle equal to? Perfect. Same angle. What is the opposite side of this angle in the big triangle? Very good. So this is our relationship. Cross multiply. X times y equals 24. And that's it. So xy equals 24. What do we know about x and what do we know about y? They must be what? Functions of course, because the man walks, so x changes, and of course the shadow, the length of the shadow on the wall changes. So they're both functions of time. Functions of time. We differentiate the left-hand side, we differentiate the right-hand side. Now I have to be very careful. Why? What do I have to do on the left-hand side? Use the product rule. There are two functions, multiply. What about the right-hand side? How much is the right-hand side? Excellent. The first function prime. Remember, you have to write a sum. So dx over dt times, very good, plus x times, very good. From this relationship that we determined, we see two rates that are related. How they are related? Through this equation. They happen at the same time and their value depends on the other. Okay, so then I'm solving for this. This is our only variable. So this is dy over dx. I'm sorry. Of course, dy over dt. I move this to the other side and divide by x. Negative y over x dx over dt. And yes, I have no problem now with x equals 8 meters. I have x, I have dx over dt. I have to determine y. But that's not a problem because I have the equation. Xy equals 24. And if x is 8, y must be 3. So then this is 3, this is 8, and this is 1.6 given in the problem from the very beginning. Before we put everything in, do you have any questions? Were you able to follow this? Any questions? Any questions? Is this okay?
Why is y 3?
Because x times y is 24. We determine the equation x times y equals 24. And when x is 8, y must be 3. Okay, so then dy over dt is indeed negative as we expected. 3 times 1.6 divided by 8. So we get, what is it, 4.8, right? Divided by 8. Oh, yeah, I didn't have to use any, of course. 0.6, what? Thank you. So as the person walks from the spotlight towards the wall, his distance increasing, it's increasing at a rate of 1.6 meters per second, but his shadow on the wall is decreasing. I forgot to copy the minus, I'm sorry. Its shadow on the wall is decreasing at a rate of 0.6 meters per second. Any questions? Any questions? How do you feel about related rates? They're not easy. They're not easy. They're not trivial problems whatsoever. No, not at all. They're not. And they're all different. I mean, I can spend the entire semester just on related rates, to be honest. Okay, so we have about 8 minutes left. So let's look at another problem. And that will complete the 3.9. And then I'm hoping that next time we will finish this chapter with 3.10 and 3.11. And a week from today, we'll start reviewing for this test. So please try to finish up everything so you can ask tons of questions. Okay, let's look at another particle this time. Here it is. A particle moves along a curve, and we are given the function. So 22 on page 249. As the particle passes through the point 1/3, 1, I don't care for it just yet, though, its x-coordinate increases at a rate of the square root of 10 centimeters per second. How fast is the distance from the particle to the origin changing at this instant? Okay, so let's give it a shot. I promise you I'm not going to hold you over. If we don't finish it in 6 minutes, then we'll finish it on Thursday. Okay, where is it? 22 on page 249. We are given y equals 2 sine pi x over 2. We are given 1/3, 1. It's x, the square root of 10 centimeters per second, so this is dx over dt. And how fast is the distance from the particle to the origin changing at this instant? So here's the graph of sine. I don't care to graph it all. And this is a point, a generic point, definitely not this one. I don't care for that. It's a generic point. And this is the point, let's say P, of coordinates x, y. This is the function that is y. Of course, this is its y. And of course, this is its x. And like before, we're going to call this z. It was declared by Jacob that we cannot use w. He said z. Okay, z it is. So one more time, let's read the problem again. A particle moves along the curve. We're given the function. As the particle passes through, I don't care. Its x-coordinate increases at a rate, I don't care. How fast is the distance from the particle to the origin changing at this instant? What do you think we're going to have to do again? No, we don't have to triangles. We have to use what? Pythagorean theorem, yes. Because this is a right triangle. So we have x squared plus y squared equals z squared. This is our y. We have to put it in. So x squared plus, can anyone tell us what to write? 4 sine pi x over 2 everything squared equals z squared. So what are we after? I should have asked you before writing anything. What are we after? Careful. Before we write anything, I messed up. Yes, that's what I meant to write first. When blah, blah, blah happens, which I don't care for. If it's after when or where, blah, 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 do not even look at it. Okay, so I found an equation that relates x and z. Now I have to find an equation that relates the related rates. What do I do? The left-hand side. Remember, x and z and x are what? Good. I'm ready when you are. Excellent. Plus.
8 times sine 2x, or pi over 2 times x.
Careful. So we bring down 2, we subtract 1 from the power, but now I have to differentiate sign. Very good. Cosine pi x over 2 times the inner function prime. Excellent. Equals.
Cosine can also be times dx over dt.
Of course, right here. Right here at the end. Thank you. Equals. Yes. Let me write this one more time because it may not be clear. Let me write it one more time. 2x dx over dt plus 8 sine pi x over 2. That's why I wrote it here, for us not to forget. And I just forgot to put it in. Cos pi x over 2, pi over 2 times dx over dt equals 2z dz over dt. So I'm just going to write dz over dt equals, I will simplify by 2. So it's just z in the denominator. And the numerator is x dx over dt plus 4 sine pi x over 2 cosine pi x over 2 times pi over 2 times dx over dt. Let's see if we can finish one minute, or we can leave it and we just plug in the numbers later. So I'm just going to put x equals 1/3, y equals 1 because those are the one given to us, and dx over dt is the square root of 10. So if you'd like to come up with that number for me, that would be great, so I don't hold you.